Hello, it's IPC Apex Expo 2023 in San Diego. I'm joined by Steve from Mechnano. Thanks for coming over.
You're welcome.
First time we've spoken, really. So actually, can you give me a good overview of what Mechnano is?
So Mechnano is a nano engineering company. There's not a lot of those in this wonderful world that we're in here in this electronic manufacturing group. But our job is to take materials and then at the molecular level introduce other nanomaterials to change those materials at a molecular level instead of what's been done in the past, which is just mix materials together to come up with something new. That's what we do.
Bit of a revolution, really.
It is. It's kind of like gene therapy. If you want to have better kids, you take your genes out, put some new genes in, and then stick them in, you have better kids. That same type of thing, but real. This is a real science. It is here today. It's not tomorrow. It's something that's available today.
And, you know, bringing that to the electronic manufacturing industry, that's, you know, you're breaking ground, really, aren't you?
Oh, a lot of ground. And we're discovering things with companies. We have semiconductor companies and aerospace companies who are realizing that their ESD protection of the past really doesn't work today. So they've been using the same thing. It's like this little guy. This is a carbon fiber ESD protection. You've seen these all over the place. You've milled them, you've used them. Well, what you don't know about this is on one side of it, it's conductive. It's not static dissipative, it's conductive, which is a problem for electronics. You don't want to put conductive. On the other side of it, it's insulative. And that's because the carbon fibers don't move their way through the injection molders the way they should. So we've had this for a long time. We just haven't taken the time to measure it to figure out if it's a problem. Well, our customers in semiconductor, our customers in aero are saying to us, this doesn't work for us. We can't use this anymore. We're throwing carbon fiber out for 8 different reasons. What we did is we took some materials, some nanomaterials, and engineered them to work inside the same polymer, and we come up with this beautiful, smooth, printable, nano-uniformed across that whole part, all 10 to the 7th. And we could say 10 to the 8th, we could do 10 to the 9th. We could do exactly what you want, not some range that won't work for today's parts. That's pretty exciting. And so you'll see your carbon fiber materials for ESD get changed out for these type of carbon materials that were nano-engineered. And you can use those in injection molding. You can use those in other types of molding, but you can also use them in 3D printing. How's that for exciting?
Well, as you say, it is a revolution, and you know, customers, they must be over the moon, really, with controlling it.
Absolutely, because today's electronics requires it. And we think, oh, that's a semiconductor problem, or that's a semiconductor packaging problem, or that problem really exists just in microelectronics. It exists for all of us, no matter what type of boards you're putting together, because those devices are on your board. And one little piece of the carbon fiber that springs out of there and becomes a foreign material will find its way on and destroy the board. We've got customers who have lost hundreds of thousands of dollars on JEDEC trays just because they were using the carbon fiber type materials. Yuck.
So it's not really a hard sell then, is it? If you can come up with literal savings.
Just a matter of letting people know. Which is one of the reasons that we're here at the show. To start helping them figure out.
I mean, you must have had quite a few people on the stand already.
And so we're pretty busy. We could do a lot more with this just besides ESD. So there's another, that's like an ESD carrier. That's 3D printed, by the way, not injection molded. That's pretty amazing that you get that quality. It's off of an SLA printer. This would be a nozzle for pick and place. That's amazing that you can do that, again, on a 3D printer. On a variety of materials, a rigid material, a tough material, a flexible material, all those types of materials. And so we have customers that not only want ESD, they want other things.
How cost effective is it, though? I mean, are these...
Very much so. So if you look at those two bars, the carbon fiber versus ours, the carbon fiber takes as much as 20% carbon fiber loading to get that job done. Well, carbon fiber is not cheap. No, ours is much, much less than that. So because we're much less, we might be more expensive tube to fiber, if you just 1-to-1, but overall, in the aggregate, we come out the same.
Yeah, right. Yeah.
So much better product, same prices,
Yeah.
looking much better.
Yeah.
That's really good.
So this would be huge, wouldn't it?
Yeah, and that's just the tip of the iceberg. If
Yeah.
you look at things like this is some of our actual carbon nanotube material in a plastic.
I'm going to have to put my glasses on. So
Now, plastic is not inherently magnetic, right?
Yeah.
Right? But if I take those the carbon nanotubes that are mixed with that plastic and I functionalize them to be magnetic,
Okay.
then that plastic becomes magnetic. As you can see, it just follows the magnet wherever it goes.
Yeah.
Now that's unique,
Yeah.
that's exciting, that's a game changer
Yeah.
for not just ESD, but for things like EMI,
Yeah.
or being able to rad hard with just plastics, or changing the way we do some of our traces to protect them
Yeah.
from crosstalk. All sorts of things. Substrates change now as you start to look at what we can functionalize.
Right. Yeah.
Underfills, adhesives, conformal coats, all of that can be improved with simple introduction of functionalized carbon nanomaterials.
So, how are you, developing this with your customers? Are you, all these things have to be a collaborative process, but in breaking new ground, it's not a case of just replacing like for like, is it? It's saying we can do this, but we can do it better, we can do it differently.
Yeah,
Are people getting on board with that?
Yeah, so there's a couple things that we look for. Can we replace like for like in the same processes?
Right.
So like injection molding.
Yeah. Yep.
Can it be the same tooling? Basically can be the same tooling. We can go right in, same process, same everything, just pull the carbon fibers out, put our stuff in, and we'll show them how they get excited about that.
Yeah.
Because you don't have to change anything else. No new equipment, no anything else. Same thing for our 3D printed parts, except they work even better because you don't have the lead times that you have for some of the injection molded or the milled parts that you have today to do your new product development. So I can get these parts that you're holding in your hand in a day.
Oh, right. Okay,
as opposed to I have to wait 6 weeks, 8 weeks for some of those parts from the miller or from the injection molder or whatever. You don't have to do that anymore. So customers are constantly looking for a few things. Can I drop it right in? Yes. Is it going to improve my cycle time? Absolutely. Because you can go with a 3D printed version and then later go with an injection molded version if you want.
Yes.
All of that will fall right in line.
Okay.
That's pretty exciting.
Yeah. And, also itself, 3D printing technology is constantly improving and changing daily, isn't it? So I guess, for you, there's new opportunities all the time as well.
So electronics has struggled to adopt 3D printing. And part of that is because they've been focused on the filament-based type printers. So you got those filaments. Those filaments do not have, again, uniformed static dissipativeness. And then they stack on top of one another, and that connection between those two doesn't allow for a really good uniformity as well. So you put those things together, and you say, okay, that was nice, that's a good try, I can use it for a couple of things, but I'm really scared that if my aeronautics customer or my semiconductor customers learn that I'm using this type of material, they're going to go, you don't ever do that to us again, right? You don't want to be that failure point. And so with these new materials, you can print them as if they came right off of an injection molder or a milling machine, and that looks just as good. I dare you to figure out if it was or if it wasn't. It was 3D printed, not milled. They say, wow, that works. It's uniform, nano uniform, not just at a macro level. It's nano uniform through that whole device, and my customers will accept me using that. That's exciting.
Yeah, that's fantastic. I mean, I can see there's going to be a lot of excitement around this at the show, and it's it's going to be huge, isn't it?
It's going to be really big. So we look just 2 customers of adoption of this, replacing on the carbon fiber. Will take hundreds, if not a couple millions of metric tons of material just to help them do their job. That's pretty big growth. We're excited about that too.
That's fantastic. So, it is great to see something like this that is actually revolutionary in the industry, because it's one of those industries that kind of grows organically, evolves sort of thing, and then every so often there's a bit of a game changer comes along, which this seems to be, doesn't it? So.
Isn't that the way we've been, though? Yeah, when we try to make changes in our industry, it's hard because you want things to work as they have.
Well, that's true, yeah.
And so even with things like our pad stacks, we got copper, and then on top of it, we put some gold, and then, we got to put some nickel in between it, and then we got to put some palladium in between it. We do all these stacks for a lot of different reasons. But if we can get down to the simplicity, if we get to that nano level, the simplest parts, we can make some adjustments to materials that'll change the world. And we're excited to work with our customers to make that happen. And yes, we have a long list of things customers would like to do, and we can't do all of them. So we take them from the top down and we start working them with our customers as to what their priorities are.
Fantastic. And actually, on a personal level, it must be quite exciting for you, having seen, the industry sort of change over the years.
Yes, it is. When I realized, and I tried to work with carbon nanotubes before.
Right.
The big problem with the carbon nanotubes is, in their discrete state as a single carbon nanotube when it was discovered, it's stronger than steel and harder than diamonds, and it conducts better than copper.
Yeah.
It's got all these great properties, and they thought we can make paper-thin bulletproof vests out of this stuff, and we can create a space elevator that goes from the Earth to the sky, to space, and the carbon nanotubes are the things that are strong enough. We finally have this material that can do all this, and what they didn't realize is that when these carbon nanotubes clump together, you don't get any of those properties. It's like rebar in concrete in your foundation on your house. If the rebar is spread out in single form, it provides a great strength and structure. But if you bundle all that rebar together, it's going to cause a problem, not be a helper. And so the problem was trying to figure out how to make them discrete and keep them discrete throughout the processes, the electronic processes, which can be freezing to then room temperature, then super hot, and then work their way up to room temperature again, right? Those processes it's hard to keep a carbon nanotube separate through all those different heat cycles. Those thermodynamics is an amazing science that we have, and the functionalization of the tubes is another amazing science to keep those tubes discrete throughout the entire process that a material goes through in its electronic formation. And that's the sophisticated nature of our science that we work on. We take little atoms and we stick things on them to keep them apart from each other. It's amazing.
It's quite mind-blowing, but it's fantastic.
Yeah.
Well, it's great to meet you again, and thanks for spending the time to talk to us.
You bet.
I hope the show is going to be busy for you, I'm sure.
Oh, so, we've had already. I'm exhausted, and it's only 3:30 in the afternoon, and I'm just too many people want to talk. People now saying to us, "Come and be in our booth. We want you in the booth to be able to talk about these things." And it's great. So fantastic. We look forward to.
It'll be interesting to talk to you in a year's time and see where you're at then.
Great.
Thank you for talking to us. Good to see you.
Good to see you too.